So this is Lab 4 sampling and aliasing. I'm first going to go into showing you my Arduino code. So here's my Arduino code. I basically serial begin, and then I try and read my potentiometer to adjust the time delay. In the future, I'll probably use something like micros or millis to try and get some better resolution on my stuff. So these are my screenshots, and you can see up in this corner, this is for our 75 hertz, and over here, the one that does indicate that it does have aliasing is this one here, which we, by my calculations, we're supposed to see aliasing, and so you can see there's unevenness about the signals, which definitely alludes to some aliasing, while the other ones are a lot more uniform with respect to that. So all these are for 100 hertz. As you can see, there's definitely some aliasing coming from this graph here, for sure. And another graph that is exhibiting some aliasing is this one as well. As you can see, these are way more uniform and constructed in a way better way, where these ones here are definitely exhibiting characteristics. So for this frequency of 215 hertz, you can see these, there's definitely aliasing coming through in these three, where this one's very uniform in its makeup, so I would say that these three are definitely exhibiting some aliasing. So as you can see, as we move up to a really high signal, there's aliasing being exhibited in all of these graphs at this point. So we can say the higher we get up in our frequency, definitely aliasing takes place. So here's an example of the work that I did in order to calculate the aliasing frequencies. So here I would create a ratio of obviously the frequency that I'm taking it at, and then with the frequency that was captured by the software. And then from there, take a ratio and then create a diagram like this, and then alias it down to figure out where what's the alias frequency. And then from there, I would put that in my table. Now, if we go to our table here, basically it makes sense. So because here we have, we're above our Nyquist frequency, we don't get aliasing. There's no aliasing exhibited here. And the same here, but as we go higher and higher with our frequency here, aliasing is exhibited for all these sampling rates. So this is definitely consistent with what we've done in class and what also the Nyquist frequency says. So this is exercise 2, where you have the square wave at 5 volts and 10 hertz of frequency, and I put this into my Arduino here. You can see that because of the frequency I have this at, the sampling rate, I'm really able to reconstruct this wave. So it's kind of tying back into the higher sampling rate. I can reconstruct whatever is put into my Arduino. And the same goes for the triangular wave. Basically 5 volts, and then I put this into my Arduino, and you can see that that wave is being reconstructed very well, and it's matching up really good to that. So it goes back to by taking a higher sampling frequency, you can construct these waves very effectively.